Welcome everybody. I am actually kind of sort of back home. I am Bastrop High School class of 2007. So I've always loved the weather, grew up loving the weather, and have been working for the Weather Service now for about 3 years. So I'm here to give you kind of a spiel about the really basics of the weather and really what severe weather is. So to start off with these two really cool pictures, one is just a rain shaft actually. It's not a tornado in the middle of it. So, but on the left side, that's actually very near our office back from October 30th. That poor mobile home got tossed on the SUV. We had an EF2 tornado, which I'll talk about tornadoes later on in the presentation, and it got thrown there on top of the SUV during that tornado. So what our mission is for the National Weather Service, it's really all about you, protecting you, protection of lives and property. So that's really a community effort. You know, Stephen Long and the whole Bastrop OEM is a big part of that. The media, so the Austin media, the San Antonio media. The City Council, so we're here in City Hall, so that's a very big part. First responders, amateur radio, and then obviously you, the public. That's why we're here, is to train you to be weather spotters so that you can be our first line of defense in the field, reporting the weather and being weather aware for us. So it's not just us back at the office in New Braunfels, but it's really a team effort from everybody doing the weather and protecting lives and property. Who the National Weather Service is, we are a team of 122 National Weather Service forecast offices all across the country. Every county is covered by one of the offices. We're one of several offices down here in Texas, but you've got offices all the way out in Puerto Rico, Guam, 3 that cover Alaska, and then all across the country. We're here 24/7, 365. Our office in New Braunfels, Texas is at least staffed with 2 meteorologists, and there are basically at least 2 meteorologists 24/7, 365 at all of these offices. So at 2 in the morning when you're sleeping, or on Christmas morning when you're opening presents, one of us is sitting in the office doing the weather, since it never stops. And we staff up and staff down as needed. So during the Memorial Day event, during October 30th, we had something like 10 to 12 meteorologists in the office, not just the 2 to 3 that we normally do. This is our 33 county area. The dot here is our office. Just down I-35 from y'all. Here we are up in Bastrop County. We go all the way out to the Rio Grande, Valverde, cover Del Rio, all the way up to Georgetown and Williamson County. We have 2 major metropolitan areas in the Austin and San Antonio area. And then the surface area that we cover, I calculated this one day, is actually about the size of the state of Maine. So from one office, using 3 radars, we're forecasting for a massive land area, and that again goes back to that partnership. And what we do is we do the standard 7-day forecast that you see on the news every day. We're also forecasting for airports, but kind of the big job that we do is the watches and the warnings. So during severe weather events, we're the ones cranking out the warnings. Some of the watches, SBC does some of those. Decision support is when we're on the phone with Stephen on the radio going, you know, the Colorado River at Bastrop's about to really jump up. You know, you may need to start evacuations, or you may need to take some action. Local outreach is basically what we're doing here. And then we also do research. So we've gone back several times and started to begin to look at those big events, especially from 2015. And that's just a picture of our office there. Nice concrete building out by the New Braunfels Airport that we work out of. So why Skywarn? I've already touched about this a little bit. Since we're just one office in this big, huge area, you, the spotter, are the first line of defense for us. Your phone call, your eyes in the field, it's letting not just us, but the communities downstream have time to prepare. So if we have a squall line coming through, it's the people in Austin calling us, letting us know the weather will help us forecast for y'all, and it's your phone calls that help us for Smithville and LaGrange and Houston and points down the stream. And the whole point of today is to train you to identify severe storm reports and how to report to us and how to get that information to us in the office. So how many people are confused by all of the color on the map? These are all of our watches, warnings, and advisories, and in the next couple of slides I'll explain at least what those 3 terminologies mean. We do cover a lot of different things. There are blizzard watches and warnings on here. There's flood, there's dense fog. So all of the colors mean something, and it's all to be able to inform you, the public, what's going on. Kind of the low tier of those 3 watch warning advisory is the advisory, and what to think about here is it's really kind of a nuisance or an inconvenience is when we would be issuing these weather advisories. So the dense fog advisory is probably one of the biggest ones we do, but wind advisory, flood advisory we do for kind of low-end flooding. So this isn't the flooding that would wash your car away, but just some ponding on the roadways would be when we would issue a flood advisory. Winter weather advisory, this isn't slipping and falling or travel hazards really, but just kind of the nuisance advisory. Going up to the watch, these we issue well in advance, so we try to issue these 4 to 8 hours in advance of a big weather event. Here are just 2 examples of a tornado watch, which is issued by the Storm Prediction Center in Norman, Oklahoma, up where I went to college, up in central Oklahoma. They issue the tornado watches and the severe thunderstorm watches for the entire country, as well as other things like severe weather outlooks, which I'll talk about in a second. Other watches, like flash flood watches, are issued here by us, the local National Weather Service Forecast Office. Any of the winter weather watches we also issue. So these really are your preparedness steps. These are saying the conditions are ripe for the severe weather, for hazardous weather, and start preparing now. So in the next 4 to 8 hours, we expect the weather to occur, and to take the action that you need to be weather aware, to maybe change some plans, to have that plan in action for when we issue a warning. So a warning is in what we issue when things are going to be happening now, when the threat is imminent. So this is a severe thunderstorm watch here, or severe thunderstorm warning, excuse me, that we issued here, and we issue severe thunderstorm warnings for a multitude of things, but this means that you seek shelter now, you take your action plan immediately because dangerous weather, hazardous weather is currently occurring. Either that we have reported from y'all, the spotter, from an emergency manager, or that we have detected via radar here, like is the case here. So our definition of severe thunderstorm, which is what you just saw in the last slide there, is large hail over the size of a quarter. A couple of years ago, we upped the criteria there from 3/4 of an inch to a quarter, just so it's really easy for y'all, the spotter, to identify what a severe hailstone looks like. So if you have a ruler, that would be basically 1 inch hail or quarter-sized, a tornado in contact with the ground, or damaging winds of 58 miles an hour or greater. So if any of those 3 things are occurring, we're going to be issuing either a severe thunderstorm warning or a tornado warning for this severe weather that is ongoing. I mentioned the Storm Prediction Center. This is another thing that they do up in Norman, is they provide severe weather guidance on a daily basis. They update this day 1 outlook several times a day, and they actually have outlooks that go all the way out to day 8. So this isn't just for us in the office or just for meteorologists, but a lot of the national media has started to pick up on these outlooks. And you will always see these 5 tiers, and you may not know necessarily what they mean. I'll explain that here in just a second. But it's really, the higher the color, the higher the risk is the kind of the nutshell of these severe thunderstorm risks. And this is what they mean. So I'll take a second here to explain things. The high risks, these purple colors, I don't think we've ever had any here in Central Texas, at least not that I can remember. The moderate risks, we get probably one a spring. We had one back in mid-May last year. It actually ended up that nothing happened in Central Texas on the day that we were under the moderate risk. But they did have a tornado outbreak up in North Texas that day. The enhanced and the slight is really what we get a lot here in Central Texas. And that just means that there's a pretty good risk of at least some isolated to scattered severe weather that's going to be possible. So the other day when we had the thunderstorms move through, we were under a slight and enhanced risk here in our area, and we had some big hailers that moved down from Del Rio and south of San Antonio. So really this kind of low end, the marginal to the enhanced is what we see a lot here in Central Texas. Numerous times during the spring, the moderates about once. And again, these high risks are really reserved for the big tornado outbreak days like you see in the Central Plains in the Southeast United States. And again, we haven't really had one of those in Central Texas. We always tell you, the public, to have 3 ways to receive weather warnings, not just one, because the power will fail or your phone battery may die. So there are numerous ways to do that. One would be the NOAA weather radio system. The annoying thing that goes off at 3 in the morning when we issue a warning. Gotta love those. So that's one thing. The news media is another, whether that's the Weather Channel or specifically local media, is really good. And then there is a big push for cell phones, both from the wireless alerts, and then there's a multitude of apps out there that give you either weather radar or weather warnings. So having the multiple ways to have that is definitely key. Commercial radio, just word of mouth. There are many, many ways for you to receive weather information. So what wireless alerts are, that is actually me a long time ago when I didn't cut my hair as often. So what happens when you get these wireless alerts on your phone is someone from our office will issue the warning, and the warning then pumps out. It's what makes your weather radio go off. It's what makes the crawl activate on TV. But for the WEA alerts, the WEA alerts, it then looks at the polygon that we drew and finds all of the cell towers within that polygon. So in this example, there's 3 here. And then if your cell phone is pinging off of one of these towers, it then alerts you. So it goes from the warning to the cell tower to your phone, and it arrives usually within seconds. Right now, the messages are only 90 characters. There's actually talk to expand those to be able to have links, since we all basically have internet on our phone now, to have links to pictures and where the specific warning is and more information. So that's currently in the works, but these occur for, right now, tornado warnings and flash flood warnings are the 2 that are really predominant in our area. There are others, hurricane warnings, tsunami warnings, stuff like that, but since we're inland here, those don't affect us. So if we issue either a tornado warning or a flash flood warning, these WEA alerts automatically go off on your phone. You can actually turn them off. When you buy a phone, they're automatically on. So to turn them off, you actually have to go into your settings in your phone and turn them off here. We also do them for Amber Alerts whenever an Amber Alert is issued, so you can turn those on and off there. We have so many success stories with this. A lot of people during the Memorial Day event said that this is what saved their life. They didn't have a weather radio, they didn't know that things were going on, but we would issue that flash flood warning, and it's these alerts coming automatically on their phone that alerted them to the danger. Another thing you can do is, how many of y'all have gotten rid of your landline phone at home? Anybody? Lots of people. I'm barely old enough at 27 to remember what a landline phone is. I think my first date I set up on a landline phone, and then I got a cell phone, and that was it. So one of the important things, though, is without that landline phone connection, when it's time for like reverse 911 and a lot of evacuation information, they don't have that your phone number anymore. So going on to this CAPCOG website, which is the Capital Area Council of Governments, including Bastrop County here, you can register your cell phone basically with your address, and it matches up the address then with your cell phone, so that especially the emergency managers would be able to have that information during evacuations. Okay, so switching gears, that's kind of a little bit about what the Weather Service is, what we do. So let's get into actually the weather now. So these are the thunderstorm hazards. These are kind of common sense at this point, but lightning, flash flooding, hail, damaging winds, tornadoes, these are the meat of what we deal with on a daily basis at the Weather Service. So looking at lightning, I like to sum up this slide as it's really hot, it's really powerful, and it's deadly, is how I like to sum this up. But lightning, it's hotter than the surface of the sun at 50,000 degrees Fahrenheit. So, that's not good. It's very powerful. 26 deaths in 2015 all across the country, that's US. For the last about 5 or 6 years, thankfully the deaths have been below average. Usually it averages about 30 to 35 a year. but we've been down in the 20s, like I said, for the last couple of years, and hundreds are injured. One of the big concerns, though, is these bolts out of the blue here. You know, if you're under a thunderstorm, you know, we say when thunder roars, go indoors, and a lot of people are inside during the event, but either right ahead of the thunderstorm or after the thunderstorm, you know, you may be outside, it may be some rain-cooled air that has moved through, and so you're like, well, this is the time that I'm gonna go out and garden or play with the kids. These bolts out of the blue can occur up to 10 miles away from the thunderstorm. So even after it's moved past and quit raining, as long as you can still hear that thunder from that thunderstorm, you are basically within range of being able to get struck by one of these bolts that come out of the thunderstorm and can strike basically without notice. This is a map of the lightning fatalities in 2015. We actually only had one in Texas for the entire year last year. Florida with the summertime thunderstorms is always high. They're basically always number one. Usually Texas is number two per year, but again, we only had one this last year. It actually occurred in Fort Lavaca, Texas. An old man was outside, kind of an outdoor vendor, and unfortunately he got struck by lightning and died last year. But all across the country, we had people die hiking in Colorado, actually playing disc golf up in South Dakota, let's see, picking berries out in Alabama, playing beach volleyball, and many other things in Florida. Actually, a motorcyclist is one of the few deaths from New Mexico, and out fishing there in Arkansas. So it's a wide range of activities that these fatalities can occur in. One thing, though, that is kind of funny is that it's us males that tend to die from lightning. And you'll actually see, I have a perfect example of this in a couple of slides. So, 8 out of 10 of the deaths are us guys here, going back to 2006 through 2014. These are country statistics, or U.S. statistics, and you see the lightning death spike here in the May, June, July, and that is one weighted again towards Florida and the deaths that occur in Florida due to their summertime thunderstorms, but it's also the time that everybody's outside. You're off work, you're on vacation, you're outside doing things, so there's more opportunity here, and then there are just more thunderstorms in general than the winter months. So for us here in Texas, it's May that usually sees a lot of deaths because we get a lot of springtime thunderstorms here in Texas, and then our summers are hot and dry, and so there's really no thunderstorms at that point in Texas to cause those lightning deaths. Here's a breakdown of activity. So leisure here is your fun that's going on outside, work-related, and then daily routine. Daily routine is just someone doing what they normally do. So going shopping, going to the store, going to see family, friends, something like that, as opposed to being outside or doing sports or anything. Again, when thunder roars, go indoors. It's the simplest way to avoid kind of being one of these lightning deaths being a statistic. Breaking down that leisure portion of the lightning deaths, you see fishing is actually a really big percentage. Why? And I have a video here in just a second of a lightning strike that occurred on a lake. So boating then and fishing really make up a big part of that beach, and then swimming. So this is all water-related activities. Trees are not a shelter, especially if it's in the middle of a golf course or out by your swimming pool or something. It's the opposite of a shelter really when it comes to lightning, obviously. So here's one example. So that is actually the lightning strike. You can't really see the bolt because it occurs so quickly, but right there is the lightning strike. And this actually came from Travis County. So this was, last year in a dash cam from one of the Travis County Sheriff's Office. I actually think this was out on 130 somewhere, if I remember, or out kind of rural area. That's another example of lightning. I like this video so much that we're just going to watch it again. And actually, you're perfectly safe in an airplane and in a car if you're in a thunderstorm. So, back I asked, is tree a shelter? And that's an emphatic no. But is a car a shelter? And that's actually a yes. And it has nothing to do with your rubber tires or anything like that. It's what's called a Faraday cage. It's the metal that is basically encasing you. As long as you're sitting in the middle of your car or in the middle of an airplane, the electricity will actually go around you and then be dissipated out again by the tires here. So it's basically giving the electricity a path out around you, so that you can be safe and not electrocuted. So planes are okay to be struck by lightning. It happens all the time, both on the ground like this and in the air. If the lightning strike in the last video had hit the car of the Travis County Sheriff's Office officer, he would have been fine. So you're safe in a car, and that's actually one of the best shelters if you're caught outside during a thunderstorm. That, though, is not good. And again, we go back to the water-related activities, the leisurely activities, and that was a big portion of the lightning deaths because unlike a Faraday cage, unlike a car or an airplane, you have nowhere to basically hide when you're out on a boat. Whether lightning strikes just off your boat or hits your mast or anything, it's going to go through the boat, and you're on the boat, and there's nowhere to hide, basically. So if you're out boating, if you're out fishing, out on the water, it's best to be really situationally aware and see that thunderstorm coming and be ready to really head in, because a boat is not a good lightning shelter at this point. So these people are very, very lucky here that it didn't strike either the boat that's taking the video or the boat that's in the picture, because that would have had some not so good consequences at that point. Flash flooding, it is the #1 storm-related killer, not just here in Central Texas, but nationally. You would think with tornadoes and hurricanes and lightning that we've been talking about, that those things would be more destructive. Well, when it comes to deaths, it's actually flash flooding. Here in Central Texas, we live in what's called Flash Flood Alley, all the way up from Dallas down to San Antonio. And it's a mix of two things. One, we have the Balcones Escarpment up here in the Texas hill country. And so we have all of this kind of rocky terrain that runs off. And we just have a perfect mix of heavy rainfall with the Gulf moisture coming up from the Gulf, and then all of the storm systems coming from the west that produce a bunch of heavy rain events. And then we have all of the urbanization that's also occurring right along the I-35 corridor. So all of that mixes to become, Flash Flood Alley. And we've heard of Tornado Alley, in Dixie Alley, the tornado focuses. But Flash Flood Alley is a world-known thing. We've had people come to Central Texas to study flash flooding. So flash flooding is really a big, big deal for us here in our area. So turn around, don't drown is our famous little spiel there. And you'll see why in just a second. In terms of flash flood deaths, we had 25 in 2015. This map shows, though, over the last 20 years, the deaths in Central Texas. We've had 143. There's been 225 in the state of Texas. So if you do the math, over half of the flash flood deaths in the last 20 years have been in our 33 counties. That is not a statistics that we're really proud of here in our area. And you can see it's really concentrated, especially around the urbanization and the urban areas here right along I-35 from Travis County down to Bexar County. And it's just because there's so many rivers now running through these big cities, and there's so much urbanization that we get a ton of low water crossings. And unfortunately, we still have people who drive through them. So not good. Don't rely on your big vehicles. I know from growing up here in Bastrop, we all have our trucks, our big SUVs. These cannot save you. These are two examples actually from the Wimberley area. The first one being from the Memorial Day event, this one being from the October 30th event. But there have been numerous big pickups and other things. And really an inch and a half, or excuse me, as little as this. So basically a foot of water, or a foot and a half of water, excuse me, can actually move your car. And the faster the water is moving, the less water it takes. So very fast moving water, even less than that, can be what pushes your car off the road. So these big vehicles, are not something that's going to save you in a low water crossing situation. So this is why we preach the turn around, don't drown. The one key fact here, nearly half of all of our flash flood deaths occur in vehicles. So switching gears, let's look at the Memorial Day event a little bit. We'll talk about Wimberley here. So early on the evening of the event, I was actually at the office, and this is what the initial radar started looking like. And you're pretty much like, well, there's not much going on here, but you've got some good training of thunderstorms going on here. Training is basically exactly what it sounds like. You get several thunderstorms that line up right one after another and go over the same area repeatedly. So that's one of the things that leads to heavy rainfall. So here in this area and then out here out west, you had that going on at the same time. So by early afternoon, this was already occurring.
They go much farther down and it's going to get out of real quickly.
Yeah,
get out going.
If it keeps raining, it's going to get worse and it will push it away.
Yeah. This guy was actually very lucky. He somehow made it out and was rescued. So this is not one of those flash flood fatalities from the weekend, but it is a very scary video to watch, and it's one of the earliest ones we saw at the office, and just kind of set the stage for the rest of the weekend. By the evening, this is what was happening, and this is what eventually led to the Wimberley and Blanco River floods here. You had a little low pressure system that set up over this area, and you can kind of see the rotation there, but it's almost constant heavy rainfall here over South Blanco County. That is going on, and you also see all the storms merging both from the north, or coming north, and coming to the northeast there. So all of that led to the heavy rainfall that eventually led to the Wimberley and San Marcos flooding. And here's the estimated rainfall. So it's widespread, 6 to 10 inches of rainfall. Basically anywhere you see the yellow, that's at least 6 inches, with the bullseye here of 12 inches right around the city of Blanco. And one of the things about flash flooding is, notice, Wimberley got 3 to 4 inches and San Marcos got even less than that, and yet they saw the worst of the flooding. So you don't have to get that 10 to 12 inch bullseye over your area to see the flash flooding that results. So that's one of the things, to always look upstream and see what's coming upstream. And that's sort of what happened here in Bastrop on October 30th, which I'll talk about in just a couple of slides. One of the things we tell people is, if you're obviously to evacuate if you're along a river, but otherwise go up. So this video from inside a home in Wimberley, this family is on the second floor as basically the floodwater comes into the house here. So that's whether it's a second story or a rooftop. There were several stories, both from this weekend and we've heard nationally, of people who were saved by, getting to the highest point of their house when the flooding occurs. So if there's not time to evacuate, go up. Yeah, that would be a very scary situation to be in. So this is the Blanco River at Wimberley. So this again is downstream from where all the heaviest rainfall occurred. You can see that basically, on a normal day, the Blanco River there is about 5 feet or so. Well, here's the trace at 7 p.m. Saturday, and it rose 30 feet in about 2 hours. So that's the definition of a flash flood there, if you needed one. And then the gauge failed, actually. So it was washed off its foundation by the rising water, and so the last point that we got was 40.21 feet. The USGS, after the fact, went back and they were able to use high water marks on the trees and debris and all to calculate that the crest was actually 44.9 feet. And if you notice, that's a good, 11 feet above where the previous record was. So the previous record dated all the way back to 1929. And all it takes is one record rainfall event to break and shatter one of these crest records. And we blew it out of the water. No pun intended, actually, there during the Memorial Day event there at the Blanco River at Wimberley. This is the Fisher Store Bridge out in that area, and this just shows flat out the power of the water. So the water rose and was able to push this concrete bridge completely off of the pilings and actually it was closed up until yesterday. They just reopened this bridge as of yesterday out there in Hays County. This is along River Road there. This is one of the houses that got washed off the foundation. Just, I believe, on the other side of the river is the home where the family of 9 was vacationing from Corpus Christi, where basically everybody except the father passed away. The only other kind of house-related death out in Wimberley at the time was an older gentleman, and then, so that's 10, and then the other 5 deaths during this weekend for us were all people driving through low water crossings. So for the whole weekend of the Memorial Day flood, we lost 15 people here in Central Texas due to flooding. We woke up the next morning to find the Blanco River over I-35 in San Marcos. Not something that happens every day, you know, water crossing a major interstate, but I-35 was closed for a handful of hours as the Blanco River said no traffic on I-35. So this is now looking at October 30th. Some interesting things of note. We had tornadoes down here that came very, very close to our office and in San Marcos. But as you notice, this really was a training situation again as rainfall set up right here basically along and just east of I-35 in the San Marcos area, and then watch down here in South Austin as well, and then as it moved up to just east of Austin. And this is all of the rainfall here, the record rainfall that fell basically over the Onion Creek watershed and over East Austin that eventually fed into the Colorado here. The crest on Onion Creek at 183, just south of the airport, was just a couple of inches less in the record flooding that occurred 2 years previous on October 31st. So these people are gonna not like late October here in South Austin. We had record rainfall at Bergstrom that occurred on that day. So all of that water is what fed into the Colorado River and produced the rise here on the Colorado River at Bastrop. So it topped out at 36.11 feet in major flood stage here, and this is what it looks like. This picture is actually taken by my dad and shared with the office. So this is the KOA RV park that's, you know, just down the road here. And so this is the record, or not the record flooding, excuse me, but this is some of the major flooding that occurred on October 30th here in town. This is kind of what a flash flood looks like. This is from the San Antonio area. You know, this nice little stream in the park, and as we sit here, it doesn't stay a nice little stream. This is 6 to 8 inches of rain, I believe, that fell upstream from this, and all the runoff got funneled into this little stream here. And notice, I mean, here's a roadway that you could drive through now. I wouldn't advise it after this point. And it happens this quickly. You know, you can go from absolutely nothing to, you know, you're not driving across that or walking across that anymore, you know, at this point. And you can notice the velocity of the water there, and this is yet another one of those cases where, you know, these people are hanging out at the park. It's not raining that much or raining at all here, and you're still getting the effects of a flash flood down this creek from rains that occurred upstream. So that's how quickly a low water crossing or a river can go from absolutely nothing into a flash flood situation. Here's an example from out in West Texas. This is out in Valverde County near Langtree, out near Del Rio. This is 12 inches of rainfall over a really condensed area, and about a 4-hour time period can do to a river. And when they turn around and walk across the bridge, it's creating a pretty awesome looking waterfall over here. Yeah.
You can feel the bridge shake.
So that's flash flooding. Moving on to hail. Hail forms, it starts out as water droplets, so basically rain that gets stuck down here at the bottom of a thunderstorm in an updraft. We'll talk more about updrafts later. And as it gets up in the atmosphere, it gets colder and eventually freezes up here at the top of the cloud. So then now you have a little ice particle. It'll drop back down, get caught up in the updraft again, and gets to take a roller coaster ride over and over in the cloud. And that's actually what produces the rings here is, you get your start, and this was from one trip, the next trip, etc. And once the hailstone gets so heavy that the updraft can't pick it up anymore, you get it to finally fall to the earth. We've measured them falling at over 100 miles an hour. There's got to be fatalities out there by being conked in the head by one of these stones, especially the bigger, softball-sized ones, but we don't really have statistics over that. So the best thing to do is if you're in a car to pull over if you see this greenish sky, just like a rainbow is produced by sunshine going through, rain. When sunlight goes through hail, you get this greenish sky. Reporting it to us, one of the best things that y'all can do as a storm spotter is put it either next to a ruler, that's perfect, or next to a coin. That is great. When you kind of just take a picture of your yard and it's got all of these hailstones, we really have nothing to compare that to. So, I'd sit here and guesstimate, those are quarter sized, but I could show that to someone else and be like, no, those are ping pong balls. So the best thing to do is give it to us in either a coin or measure it. And even if that's not a picture, that's the phone call too. And one of the classic things we say is don't call us up and say it's the size of a marble, because there are marbles that are that big and there are marbles that are this big. So the coin is really the best thing that we can immediately relate there in terms of hail size. These are all the large hail reports in 2015. You notice the concentration just on the east side of the Rockies across the Central Plains. And then also you can basically pick out population centers. So, there's the I-35 corridor there, and some of the big cities across the southeast. The more rural it gets, the less reports that you get. And again, the really big concentration for hail is across the Central Plains, climatologically. This is that example of how men, die, from lightning. We're just going to sit here and bask in the glory of I really don't know why in the middle of a hailstorm, it's the best time to cut grass. But, this is not a good thing. A shirt is not adequate hail or lightning protection for that matter. Okay. Moving on. Excuse me. These are all the straight line wind reports from last year. Again, you can see the concentration to the east of the Rockies. And the main reason for this is how many trees do you have out here in the middle of the western United States? Not that many. So really, especially across the southeast, where you have a bunch of trees, and again, you really can see in the rural areas how the reports drop off there for straight line winds. One of the biggest threats in terms of straight line winds are what we call microbursts. These are a bunch of rain and wind that is actually dropping out of the bottom of a thunderstorm. So you get this initial stage when it's basically descending from the cloud base, and again, all this is a bunch of really cold air dragging rainfall with it down to the ground. And once it hits the ground, it can't go anywhere except for out. So think about a microburst as your faucet in your tub or your sink is basically what this is. So this is when the strongest surface winds are generated. These things used to be a big danger to general aviation and to aviation. There was, I believe it was 1988, a Delta plane that was downed at DFW by one of these things. Nowadays, we have enough detection that that's not so much of a problem anymore. And then once these things hit the ground, they spread out again in all directions. You can get a little rain foot here. So a lot of the times we'll see kind of a curlicue occur on the end of these. And these, again, are cold air coming out and then spreading out in all directions with the highest wind speeds. Here's what one microburst can do, actually, out from the McDade area last year. It can do that, and just like that, your shed's gone. So again, the microburst could have been occurring over here and all of that straight line wind pushing out in one direction, toppling the shed there. We'll watch it flow away one more time. Here's an example from the New Orleans area. So again, in the middle of a thunderstorm here, and here's this Cane's chicken that this guy is at, and that's kind of a railroad trestle, excuse me, there, and something is about to happen. Timber. So the wind was strong enough to push those railroad cars off of the railroad trestle there and cause the power outage. So this is some examples of straight line wind damage. A lot of what we see is big trees, fence lines, and all that are blown over, telephone poles. But you know, when we get one that goes across an airport, or these are big chicken farms like what we have down in our area and out towards Gonzales, we can get the sheet metal roof gone, or you know, they can easily flip one of these really, really light planes. So we're talking here 50, 60, 70, 80 mile an hour winds, all pushing out in one direction at one time with these straight line winds. Small outhouse buildings can be gone. I don't know about the lifetime warranty on this shed anymore, but this is from the Hondo area last year, one of Paul's pictures from a storm survey he did. Again, this is all straight line winds, so not tornadoes yet, we'll get there, but yeah, he thought this was a pretty funny picture. Is this left over from Del Rio?
It was. I did Del Rio Skywarn 2 days ago when I was showing them the big hailstorm that just came through Del Rio.
Okay, so this was from, I think, 2 or 3 nights ago. Big hail, we had inch to inch and a half hail. Not really relevant, but that's left over from the...
What happened out there, they had wind-blown hail, like 60 miles an hour. Every window that was westward facing was pretty much broken out in Del Rio, out there. That was made it.
Yeah. Okay, so switching gears to tornadoes. Here are the tornado reports from 2015. Here's ours from Central Texas. These again are reports, so not all of these are verified and have been gone through. But I mean, it's still almost 1,300 tornado reports. Again, you notice once these storms get over the Rockies, it's the Central Plains here, which is the classic tornado alley, and then Dixie Alley here in the southeastern United States. You can even notice, you know, kind of tracks of these tornadoes as you look closely here through the reports. So there's an important distinction here of a funnel cloud versus a tornado. Funnel clouds, here are several examples. I believe this is the one that was taken from near Cedar Creek High School, looking kind of towards the north. Funnel clouds are rotating columns of air, but the important thing is that they are not in contact with the ground. So all of these, you can kind of see that there is space between the ground and where the rotation occurs. We still want to know about these, and we'll get to that and kind of identifying funnel clouds here in a little bit. But yeah, it's not a tornado until it makes contact with the ground. This was one of the tornadoes, I believe, back from the May event out in Fayette County here. It was a weak tornado, EF0, EF1. These are the majority of the tornadoes in our area, over 80%. They cause a low percentage of the fatalities. They really only last as long as basically this video. Once this video was over, I think this tornado lasted a couple more minutes and then dissipated. The winds here, if you notice something, it's up to 110 miles an hour, basically equivalent to the straight line wind damage that we've been talking about. So a lot of the time people are like, well, I got hit by a tornado, and we have to go out and do the survey to be whether it's a tornado, one of these weak ones, or whether it's straight line wind damage. They really are difficult to detect by radar. They may be there one scan of the radar and gone the next, so it's difficult to get confirmation, and many do go unreported. This is actually a Giddings tornado from last year that happened, and the funny thing about this, remember how I said that they're hard to detect? We thought this was a rain shower on radar. I was on shift this day, and we got a call of a tornado in Giddings, and we were like, okay, it doesn't look, you know, rather threatening. And then when we got a second and a third call, we're like, okay, we better put the warning out because this is legitimate. And then we started getting these videos, and this ended up being a zero, an EF0. So again, the weakest of the tornadoes didn't really do too terribly much damage. But again, they're harder to detect, but they're the less violent and the less really threatening if you're looking on the tornado scale. But going up from that, we have EF2 to EF3 tornadoes. These are the mid-range tornadoes. A larger percentages of the deaths here. They're on the ground longer, and so that helps them be more identified by radar. So we're pretty good at detecting these, getting warnings out on these. We had 2 of them last year. Both occurred on October 30th, one down in Floresville, and then the one that went within basically a mile of our office were both EF2 tornadoes. And so these we get a little bit more here in Central Texas, almost 20%. But we get, again, good warnings and good verification on these tornadoes. It's these violent ones that occur less than 1%, but they cause the most fatalities, and these are the ones that are 200 miles an hour. This is the Tuscaloosa tornado, from a couple of years ago. These can be on the ground for 20 to 50 miles for up to an hour or two. Again, these are common out in Alabama, a lot in Oklahoma. The last one in Texas actually was the Gerald tornado from 1997. There has not been an EF5 tornado in Texas since the Gerald tornado. So we're kind of due for one, unfortunately. There's been several EF4s back. I believe there was an EF4 out near Dallas on the 27th of December of last year, but again, the last EF5 was actually Gerald. So really, ingredients of a thunderstorm, we have recipes for basically everything, not just food. And so you need three things. You need moisture, which we have plenty of from the Gulf of Mexico. Instability, which is just basically an unstable atmosphere. And a lift, which can come from either daytime heating or a cold front, many sources of that. So when we get those three ingredients that we look for, you get basically just ordinary thunderstorms. And so they start out, in the summertime, it's just some towering cumulus. Think about a summertime afternoon when we sometimes get these thunderstorms. And you get all of this upward motion in the air. It follows with the cloud. This is the updraft that I was initially talking about. So you get the air pushing up. You don't really have any rain yet in this initial stage, just the growing cloud, until you get to the mature stage of the thunderstorm. So once we get to the mature stage, we have both an updraft and the downdraft, which the downdraft is really where the rainfall is occurring. So think of the updraft as the air going up and the result being the rain coming down in the downdraft. So what it does, though, is it drags all that air, sort of like the microburst, and you get this rain-cooled air, this exhaust. So now start thinking of a thunderstorm as an engine where you've got the gas going in and the exhaust going out. And so what happens is they briefly coexist, but as all of this exhaust starts coming out of the thunderstorm, it cuts off the warm air coming up. And so now you just have all this cold air, and what happens is you get this dissipation stage. And so now it's just all of the cold air going down and spreading out in all directions. And only the updraft remains, and the thunderstorm dies. And that usually occurs in only about a 30-minute period to an hour period. Again, most common for us here in Central Texas during the summer months, when we get like the sea breeze coming in, or just the daytime heating of the afternoon being enough to kick off one of these ordinary thunderstorms. This is what they would look like on radar. So you can notice it kind of pulse up, and then these lines coming out are outflow boundaries. This is actually the cold air pushing out from the thunderstorm. So as it kind of gets more obvious, you notice that they weakened here. So they start pretty strong. Then you start getting the cold air to come out. They weaken a little bit, regenerate, and then especially right in here, they really weaken. So that's what the life cycle of one of these ordinary thunderstorms look like on radar. Multi-cell thunderstorms is when you basically have all three of these stages going on at one time. Is you start with your towering cumulus, you get a mature stage, and then you get a dissipating stage, and they basically line up one after another. So in here, you can start with your towering cumulus in the bottom left of the video, then you have your mature thunderstorms, and as you get the thin wispy clouds here, it's the dying thunderstorm here, and you just get them to line up, and so one after another, they'll develop, go, mature, and die, while another one follows in its footsteps. You need a fourth ingredient to get the severe thunderstorms, to get the bad boys that produce the large hail, the tornadoes, and that is wind shear. So we get that a lot when these big low pressure systems kick off the central plains. And so what that does is that then tilts that thunderstorm. So, it was really vertical in the last couple of images that I showed you. Now we're getting the tilting due to that wind shear. And so what that does is that allows the downdraft to come over here away from the updraft and put all the exhaust out here. So now you're not getting that cold air that cuts off the updraft. So now you have an updraft and a downdraft that basically continue to function and don't cut each other off, and you get these long-lived bad thunderstorms. So single cell, multi-cell, the threat's relatively low. You can still get hail, you can still get some pretty good winds out of these, and rarely a tornado, but it happens once you start getting into the squall lines and the supercells. That's when the threat really does begin to kick up at that point. Some visual clues of these, what makes a, just looking outside, that it's a severe thunderstorm, that it's one of these bigger ones, is you can get these kind of crisp edges or cauliflower appearance that really shows that there's a ton of air moving up in the atmosphere and is basically hitting the stratosphere here and has nowhere to go. So really, the prettier it looks, it's probably a severe thunderstorm capable of doing some damage. So the ones that make you go, oh, that's cool. Yeah, it's not cool for the person underneath the thunderstorm at that moment. It's cool for you, though. Again, this is an overshooting top, so this is actually an updraft that was strong enough. While the majority of the storm here, as you can kind of see the crisp edge, that it hits the stratosphere and can't go anywhere, right where the updraft is, it was strong enough to actually kick up and break into a whole other layer of the atmosphere, up into the stratosphere. So you get these overshooting tops that really indicate just really strong updrafts. Here's actually one from another example from the Giddings area. So this picture was taken looking on the radar image from kind of down over here, looking towards this thunderstorm and this thunderstorm. This one is that one, that one is that one, and you had baseball hail over Giddings. So again, it's fun for you to look at, pretty for you to look at, not pretty for the people in Giddings who are getting baseball-sized hail. And this is actually what it looked like from a southwest plane that was coming in from East Texas that was making a landing at Bergstrom. Out here away from the updraft, it's pretty safe for these airplanes to fly, but you can actually see the updraft kind of being tilted up. That's the indention in the cloud here. So these are really, really strong supercell thunderstorms. Other visual clues, you'll get this dark cloud base here, and really what you begin to see is the updraft and the downdraft here at the base of the cloud. So where the updraft is, where all of this air is rushing in and up in the thunderstorm, you get basically no rain. And then over here, where everything is coming down, is where you get the large hail, the rain, the gusty winds coming out of the downdraft. So the area where a tornado would potentially form is in this updraft region. This is, again, the region where all the air is moving up into the thunderstorm. And that's where the wall clouds would be. So typically, here in Central Texas, we have so much moisture at the surface that the wall clouds would look kind of raggedy like this, and they're really hard to differentiate. Is that a wall cloud, or is that what we call, virga or scud clouds, which I'll talk about in a second. And really the way to do that is just to watch this. If this is rotating, that's probably not a good thing. And it could potentially produce a tornado. If it's just kind of hanging out right here, then it's probably scud cloud. But so these are wall clouds. Another example is this one here. As we watch this video, you can actually see the rotating cloud base over here while you watch the downdraft over here. So watch here, and you can actually see it rotate. And two, you can notice all of this air just flowing up into the cloud here in this updraft region. But this is where the tornado would develop. You can really see the rotation now going on here. And this whole part of the thunderstorm is rotating. And that's really what defines a supercell, is any rotating thunderstorm. Just because it's rotating doesn't necessarily mean that it's going to produce a tornado. I mean, it may just produce a bunch of large hail or some damaging winds, but really this could be a precursor definitely to a tornado.
Is the rain-free base usually in front of or behind the thunderstorm?
It's usually kind of on the tail end. So here in just a couple of slides, I'll show a schematic kind of a supercell, and I'll show you where the downdraft would be and where the updraft would be. But it is kind of usually on the southwest end of a thunderstorm is where the rain-free base would be. Good question. So another thing to look at, though, is a shelf cloud. And what the shelf cloud is that it's actually associated with the downdraft over here where the wind and the hail would be. So the wall cloud, again, rain-free is what to look at for the shelf cloud. That's the tornado or updraft region. The shelf cloud usually looks a lot like this, and this is basically harmless. It may look really bad, it may look like what's going on, but it's the rain-cooled air that's coming out of the thunderstorm that creates this cloud coming out. Usually it does get windy, so you could get some straight line wind damage from this, but this is what passes by, and it feels nice, and you can feel the noticeable difference in the air. If you were standing here, this person is going to get a really big gust of wind and get some really, really cool air coming out here in just a second. So this is a big shelf cloud, I believe down from the Corpus area. One of our forecasters took this. And so this comes out on the leading edge of that gust front, again, that I showed you on radar a couple of slides ago. And this is cool air associated with the downdraft as opposed to the wall cloud, which is in the rain-free base associated with the potential tornado development region. Other visual clues of really, really strong thunderstorms are what's called a flanking line. Basically, this is just new clouds that are being developed as it feeds into the updraft region of a thunderstorm. So you can see kind of the shape there and the shape there as well. Squall lines are just a line of moderate to strong thunderstorms. A lot of these produce bow echoes here, and really the main threat with these squall lines will be your outflow winds here that come out ahead of the squall line. With your outflow, again, your shelf cloud would be associated with these. Quite often they are severe. These things can march all across both Texas and the country. They can stretch for hundreds of miles. Again, hail and the damaging winds are the biggest threats. They can produce tornadoes. You get little vortices that develop on the leading edge, but hail and damaging winds are what we look at with these squall lines. So here's just one marching through the I-35 corridor here. So again, you can think of each of these as a little individual thunderstorm, but they're all lined up, one right next to each other along the squall line. A shelf cloud, again, is a good indication of some moderate to high winds. This is the Indiana State Fair from a couple of years ago, and unfortunately, this is what happened. Is a line of thunderstorms was off to the west, and the shelf cloud, with all of that cool air and the high winds, came pushing through, and it blew over the stage at a Sugarland concert again at the Indiana State Fair and killed a couple of people. And this is what it looked like on radar. So, all the bad thunderstorms are back here, and you may think that, oh, well, I've got another 30 minutes to an hour before I've got to take shelter or evacuate. But you have this thin line here showing the gust front well the squall line here, and that's where the gusty winds is, and that's what blew over the stage. So, as you can see, the line crossed where the fairgrounds were.
The gust front is the outflow boundary?
Yep. Mm-hmm. Yep. So supercells, again, these are the things that threaten life and property. The wind shear is what's needed for these things to occur. They can be long-lived, lasting over several hours. The rotating part that I was talking about is the mesocyclone, the rotating updraft. And they're usually out by themselves. You don't really get a lot of supercells that hang out with anybody else. They're kind of loners, but they're pretty bad. Here's a supercell and a very beautiful image, a couple of movies from the Texas Storm Chasers. And again, you can see here the updraft here, how it rotates and wraps around the thunderstorm. You have the downdraft here on the backside of the thunderstorm. So this is an amazingly beautiful example of a supercell here from last year. And again, this out here is the rain-free base of the updraft, and then you have the downdraft back here is where all of the rain is falling out of it, and it's just so pretty to watch. Yes, from afar, exactly. And here's that schematic that I was talking about. So your rain-free base would be out over here at the back of the storm where the wall cloud and the updraft would be. This is kind of the classic hook echo that you would see as the mesocyclone is kind of in that area there. And then as you get to the back of the storm, you get kind of the updraft region, the shelf cloud, and the outflow would be kind of out here in the back of the thunderstorm. So to answer your question there, On the back side of the storm is where the rain-free base and the tornado would be. Up towards the fronts where you get the heaviest rainfall. All the big hail would be occurring kind of back in this region, and the outflow and the heaviest rain is all back here as well. Not all supercells produce tornadoes, like I said. You can get 100-mile-per-hour straight-line winds, and this is what happens to our poor radar. So this sort of like the example that Paul was talking about from a couple of days ago. These are big supercells that develop out here, either off the Mexican mountains or kind of out in the mountains of West Texas, and kind of plow through the Rio Grande Valley, and this is what can happen. So this was 100-mile-an-hour winds and some fairly large hail dented in our radar out that's in Bracketville out there, and I believe it was out of commission for something like 3 or 4 months while they repaired it. So again, not all supercells produce tornadoes, but large hail and very damaging winds. So any supercell is not something to be messed with when it comes to weather and forecasting. So some spotting techniques. Again, tornadoes may be partially invisible or obscured, so you're looking at this and going, okay, well, funnel cloud or tornado? The thing to look at in this case is the debris at the surface. So the fact that there's debris at the surface being kicked up by both of these thunderstorms, or both of these, funnel clouds and tornadoes, means that it's a tornado. Means that there's rotation, even though you can't see it, there's rotation going all the way to the surface, and so these are both actually tornadoes here because the rotation is there. The one tornado that I have seen ever happened in Norman, Oklahoma, and it was one of these. I looked up and I saw the funnel cloud looking part, and then I looked down and I was like, oh look, there's debris at the surface. So it was a tornado. It wasn't a complete tornado with a lot of condensation and debris here, but it did make the connection to the ground. The other thing is they may be rain wrapped. Partially obscured by rain is another potential threat for these tornadoes, and that's when it really gets dangerous, especially for you, the spotter, or any storm chasers out there, because you don't know where it is at that point. You don't really know what's rain and what's a funnel, so they could be obscured by rain. And then these are the tornado lookalikes that I was talking about and have mentioned. So non-rotating low clouds with some scud. Again, this could be slightly confusing in the rain-free base region, and really what to look for here is it rotating? You know, again, if these are just kind of hanging out or moving just upwards into the cloud, it's most likely scud and not a funnel cloud. Or these little tail clouds, again, are associated with the upward motion going up in the updraft. And again, just look for up, not necessarily rotating. So you may have to sit there for a second and see what's going on, whether it's rotating or whether it's just more one-directional motion or it's just hanging out. So there are a bunch of tornado lookalikes out there. There's even some more. This was actually a picture taken from very near the San Antonio EOC, and someone came out and was like, oh look, it's a tornado. It's actually not, and I can show you why on the next slide. It's an industrial stream, so it's a plant here that was producing something, and it was going up into the low cloud base, and it looked very much like a funnel and a tornado because of all the trees and the obscured view. Or rain shafts of dissipating thunderstorms. So this is a pretty picture of a dissipating thunderstorm right at sunset, and just the way that everything's set up with the sun behind it, you know, it looks sort of like a funnel. Well, it's a dying thunderstorm with all the clouds flowing off the top, and this is all just rain dumping out of it, and the kind of little rain foot even there at the bottom. But again, not a funnel, not rotating, but it certainly looks like it. So this is basically the setup for this picture here. So again, looks like a funnel taken from here on the south side of San Antonio, and it's looking out towards Calaveras Lake. They have a plant out there, and it's actually smoke or something coming from this stack going up into the low clouds. So this happens a lot out actually in the New Braunfels area where we have the quarries going on. If it's a low cloud morning, I mean, I can be driving to work and look to my right and be like, oh, look, it's smoke going into the cloud, but it sort of looks like a funnel. So again, important to not just see that and gut reaction be like tornado, but kind of sit there for a couple of seconds and watch it and really see what's going on. So spotting techniques, what is it? Just kind of a general overview from what we've been talking about a little bit. Anything that's a smooth appearance, touching the ground or rotating, tornado, something smooth, not touching the ground, rotating would be funnel cloud. And anything that's ragged is really the things to watch for. So that could be scud, again, that could be these industrial streams or rain shafts. They can exhibit the rising motion, the upward motion, but not necessarily rotating. So what do we need to know about? Well, we need to know about the tornadoes and the funnel clouds. The tornadoes, obviously, because we need to get that warning out, or its verification for a warning. The funnel clouds, just because it could possibly turn into a tornado basically at any moment. So some spotting techniques: know when you're getting too close, especially, you don't want to be caught in a car in a tornado. Very bad situation. So, we're not trying to get you to go be storm chasers. No, we want you to be safe doing this from the safety of your home. But in many cases, people get too close and they kind of can't see what's going on. So being back away from the thunderstorm is best. And that works out. As we've talked about, there's a rain-free base where the tornado should be. So you can be, a couple of miles away and you're not going to be obscured by rain. You're going to be able to see what's going on. So it's really some good spotter techniques. We tell people to be aware, to have good communication, know where some escape routes are, and know also where your closest shelter is going to be. When it comes to flash flooding, if you're driving along, and that's a pretty good drop off down to where this river is, but if you didn't know that was there, and this is again why turn around, don't drown is so important, you could drive up and be like, oh, well, the road's straight across, and oh, that's a couple of inches. Well, no, it's a couple of feet difference. So you're gonna drive off into here and be down here floating down the river. So again, water flows faster, is deeper, and hides many of the dangers than it appears. So never assume that it's just a little bit of water. It could be a lot. Whoops. In a home, the safe place is in a closet or an interior room, interior bathroom, hallway on the lowest floor of your house. A lot of the times we see examples that are just like this, where the roof is gone, maybe a wall is gone or damaged, but the family was inside in a bathroom taking shelter. I can remember a case back a couple of years ago in 2012 on a storm survey I did. It was a Burnett County EF2 tornado, and it was the one house that the tornado hit, but the family was inside in their bathroom. The kids were in the tub with a mattress over their heads. The house was actually picked up. It was on cinder blocks, picked up, moved to a football field, and everybody inside was fine. So it really does, these precautions, a lot of people are like, well, the tornado might wipe this and do that. No, they save lives when people take shelter in these interior rooms. And really what you're doing is you're protecting yourself from a lot of the flying debris, is what you're really trying to put as many walls, as many barriers between yourself and that outside flying debris as you possibly can, because that's really what kills. It's not the wind speeds, it's nothing like that. It's the debris that you're really protecting yourself from. So the worst tornado shelters are mobile homes. Going back, remember, to the EF scale, we briefly talked about the EF0s to EF5s. This can happen even in an EF0 or an EF1 tornado for a mobile home. So if you live in a mobile home and there's basically any threat of tornadoes, you really need to have a plan to get to somewhere with a sturdy shelter or somewhere to take shelter, because even though the weak tornadoes can topple a mobile home. Vehicles can be picked up like matchbox cars and thrown, so never ever try to outrun a tornado. It's so much better to stay in your house and take shelter there. School buses, same reason, excuse me. And highway overpasses in the last couple of years, we found out, are actually really dangerous. At one point, I think the science was telling us, oh, well, if you're out driving, it's a lot better to be up under here than in a vehicle. But from several cases in Oklahoma, we discovered that this basically acts as a wind tunnel, and you have the debris flowing under here at even faster speeds, and it's just not a good option. So if you're out driving a car, so the common question is, well, then what do I do if I'm caught out? If you're out driving a car, either try to find some store or somewhere to go inside and take shelter, or actually find a ditch. And what you're wanting to do there is, again, it's all about avoiding the debris. So you want to get down kind of below ground level, cover your head in a ditch. Granted, the thing there is be wary you're in central places of flash flooding. So be very aware. We've actually had a case where a family member has died because there was a tornado coming, they took shelter in like a culvert or something, and then it filled with water, and that was a very unfortunate situation. So, but yeah. Again, flying debris is what we're trying to avoid. This is actually the home that I was talking about in Burnett County. So it's 2014, not 12. But you know, here's a 2x4, something that's, you know, halfway into the wall here. Here's another one from the Austin area, another example. This is an example of some, you know, Texas tornado damage indicator, right along the barbed wire fence there. So this is what Paul was talking about, what to report to the Weather Service. I'll get to the kind of the what on the next slide, but this is that important 1-800 number. It's on the card that y'all all have. It is an unlisted number that basically only we give out to y'all who come to our Skywarns, so that you have it. It always rings to the operations area, so you call that number, you get me, you get Paul, you get one of us, 24/7, 365. When you call us, what we're wanting are three main things. What time is it? So are you calling and you're looking at the quarter-sized hail right now? Did it occur 5 minutes ago? So what's happening, or when it happened, what is happening, hail, tornado, high winds, and then your location. So we really like locations. If you can give us a cross street, that's the best for us. If you know your latitude and longitude, that's great too. Don't just be like Bastrop, Texas, because are y'all out by the high school? Are you know, down by HEB? You know, we need to know for our verification purposes and just kind of so we can correlate it with radar exactly where you are. So cross streets are best if you want to give us your address, stuff like that, but that's kind of how we like location information. If you see something out on the highway, if you're traveling, yeah, call us, because if you're in our area, you can get that report to us, and we may still like that. If you're in someone else's area, we can very much figure out who's, you know, which of those weather forecast offices you're in, and we can relay that to them. So yeah, if you're not in our area, feel free to give us a call still, and we'll get the report either to us or who it needs to go to, definitely. So what to report? Tornadoes, rotating wall clouds, funnel clouds, all associated here with tornadic, you know, supercells, and then a little side note or whatever, it's hail of any size, winds, and then extreme rainfall amounts, and obviously flooding. And what I mean by extreme rainfall amounts is if you're getting 4 or 6 inches of rainfall in an hour, or if you've picked up 10 inches of rain in the last 5 hours, that's what we need to know. And that's what we mean by extreme rainfall amounts there. Any flooding at low water crossings, anything like that. Wind damage as easy as your, you know, fence blown down, big trees, and then again, hail of any size. And that goes back to you're helping the person downstream. So if you're getting only dime-sized hail, nickel-sized hail, go ahead and call us, because we can then look at the radar and be like, well, this thunderstorm is actually on an upswing and it's getting stronger. So if you're getting nickels, well, then it might be quarters by the time it gets to Smithville. So hail of any size is definitely something we want to know. Quickly, how to report. You can report to us online. In addition to the phone calls, you do that through our website. You can do weather.gov/Austin. We'll get you to our homepage here, and then on the top right corner, so this is what the homepage looks like. We're going to zoom into right here. So just on the top right of our little warning map, you can hit Submit Storm Report, and this is what you get, and this really breaks down that tell method of give us what the event is, give us the location, give us the time, and then we love contact information so that if we have more questions, we can give you a call back from these online reports. The cool thing about this online report, you're like, well, where does this go? What happens? This alerts on all of our computer systems as soon as you hit that Submit Report button. So we get basically an alarm that says you have a new online report. So don't think that because it's online, it goes onto some server and disappears. We get it instantly at that point for these online reports. Social media, I'm one of the social media focal points at our office. If you're on social media, this is how you can follow us. We are at NWS San Antonio on Twitter. If you search NWS San Antonio on Facebook, you'll find us. We're also on YouTube, doing a lot more with YouTube now. And so you can actually submit reports through that. We love getting tweets with pictures, Facebook comments with pictures. And we're always on both getting information in and putting information out. So if you have questions and are really, really tech savvy, feel free to contact us this way. Not just in severe weather, but general weather questions and all, general interactions, sunset pictures of blue bonnets. You know, we get everything. So the pictures of the blue bonnets and all are really the popular pictures. And I'm like, I just issued a severe thunderstorm warning, folks. Come on. I don't know. That's the realm of social media and a conversation for another day. But we do like this hashtag on Twitter. So you can either tweet us directly at this NWS San Antonio, but if you include this hashtag, we also see it. So it's hashtag EWX, which is our office identifier. So hashtag EWX spotter will get us the report right to us on social media. We do have a mobile website. Probably the question that Paul and I field most from these Skywarns is, do y'all have an app? We don't, unfortunately. But we do have a mobile website that works just like an app would. And you, both on Android and on Apple phones, can save it onto your home screen. And it will work just like an app here. You click on it, and you can get all of our updated weather information through that. So it's mobile.weather.gov. So just add mobile in front of weather.gov there. You can. We tested this yesterday, right, Paul? There's a report button from here. So, and you can actually tweet us too. So there's the report button, and there's an option to tweet us a report, both from this mobile.weather.gov. Mm-hmm. I believe so, yes. When you open it basically to this screen right here, it'll pop up and be the whole, you know, can I access your location, and it'll automatically find where you're at. So you don't necessarily have to know your zip code or type in your place. So this will work, you know, if you're out traveling or whatever too. MPing is another method that you can use to report. It is an app, and it's a partnership between the National Weather Service and the National Severe Storms Lab, which is kind of the science branch of the National Weather Service from up in the Norman, Oklahoma area. And this, you aren't limited to just hail, but rainfall reports. This started out initially kind of as a snowfall reporting and a winter weather reporting mechanism, so you can download that on both the Apple and Google Play stores. All of this information here gets, again, automatically fed into our systems, so it's an almost instantaneous way to report to us there in the weather office. So let's talk about CocoRaws as I wrap up here. We love CocoRaws at our office. What it is it's a public and open to everybody, basically, network of rainfall observers. So you go to CocoRaws.org, you get all of these different maps of the rainfall that's being reported, again, all across the country. Even if you aren't a CocoRaws observer, all of this rainfall data is freely available to use. You know, if you need to check how much rain fell, you can get all the way down to the county level. So you can look at the CocoRaws observer map for Bastrop County and see how much rain fell across the county here on this website here. Whoops. And this is just basically what the submission form looks like. So once a day, you would get online with, once you have your rain gauge, which you can get through this CocoRaws website, once a day, around 7 a.m., you would just get in and put in how much precipitation was in your rain gauge for that day. 3 years ago, I went to my dad and I was like, you know what, do you want to do CocoRaws? I can get you a free rain gauge. And he was like, sure. And he's been doing it now for the last 3 years every day. Shocks me that he still does it, but I'm like, okay. So, and we're actually giving away, as Paul said, we're giving away one of those CocoRaws rain gauges at the end. So make sure you've filled out your spotter information form. Yeah, even he does zeros. So yeah, people can put in zeros. They do have an app now. Again, if you're tech savvy, you know, or always on the go, you can have an app to allow you to put that in that way on the go. And again, this is just what the map looks like on a national level, on a state level, and even on a local level. So again, every single one of these dots, in fact, I see the one that's my dad's dot. I won't point it out, but anyway. But this is what a local level looks like. And again, we have the scale, and this gives us the really high density rainfall reports. That is what your rain gauge that you would buy from them would look like. It's about 30 bucks. That is an inch worth of rainfall, I believe. And then that's 11 inches? 10 inches, yeah. So basically, if you get more than an inch, it starts overflowing into the outer bucket, and yeah. Continue to do that. Mm-hmm. Yeah. 10 inches of rainfall, yep.
That is record. I have 2 water gauges at 3 foot distance. They never measure the sea. And about half each.
It should be a lot closer than that.
Yeah.
A neighbor of mine is an ex-National Weather Service meteorologist. He lives 2 acres away from me, so 2 lots away from me. And even during the most significant of rainfall, we will be fairly close, within a couple of hundreds of each other. Now, there could be a pretty substantial, maybe even a quarter inch of rain. You are right on the edge of that heavy rain, but especially if they're a couple feet away, there shouldn't be that much.
Exactly.
Yeah.
So obviously, I need it.
Need a good gauge.
Yeah.
That was about 9 minutes.
Right.
Yeah.
When you get your Supercells gauge, there's instructions on placing it.
Mhm.
That has a lot to do with it.
Yeah.
And I know I put it away from any obstacle.
Right.
Yep.
They don't have any excuse.
A lot
Yep.
of people ask me, well, what do you do when it's actually raining? And believe it or not, this time a couple of times in my talks, I come across some Microbursts members that actually have 2 gauges. And they'll actually go and just swap out the gauges during the rain events. You don't miss any rain at all.
Yep.
Because otherwise, you will have to quick go out the gauge, quick go and measure it inside, and bring it back. You actually miss some rain. But if you actually get 2 of them, you can actually swap them out. And that's above and beyond, I guess I would say. They're gold star Microburst members. We're just looking for Microburst members.
What do you do?
That's an embarrassing. I don't have 2 gauges.
I think. So again, you just get these really, really localized reports. And one of the benefits of this, we don't have a slide showing it here, is being down to the street level. Our ASOS gauges, our surface observation stations are basically at all the airports, so they're miles and miles apart. This gets its really, really high density. So we had a case a couple of years ago out here near Canyon Lake where we had one gentleman who got lucky and got like 10 inches of rainfall. I don't know if 10 inches of rainfall was lucky, but a thunderstorm set right over him, and he was the only Cocoros observer under it. So you saw, a tenth of an inch or a half an inch around him, and then one rain gauge luckily got caught under that. So that's the street level for Cocoros. And that is the end of our basic presentation. So I can take questions, Paul can take questions, and we'll take a little bit of a break.